Have you seen similar code before? In my case, it's even worse. I have written similar code before, but I actually have two issues with that code. Issue number one is that, in my opinion, it's really hard to read. Someone might say, oh, dude, but it's just 3 if statements. Yes, but there could be easily a lot more if statements, and even those statements we have now, they are hard enough to read. The problem number two, when the requirements change, and then there will be more event types, for example, or less event types, but let's say there will be more event types, this code is not automatically aware that it needs to handle those changed types. Let's have a closer look. So here's this function that will map some output based on the event type, some events, and then we try to create the log out of those events. If we run it, we will get our results back, so it's perfectly fine. In my opinion, this code is really hard to read, because it's really hard to focus what is going on. So when like if type start draw, then do, else if, so it's quite hard to keep focus of what is going on. One way I would try to fix it is by using a lookup table. Now we have this lookup table that does exactly the mapping as it was before, but now, in my opinion, it's so much easier to read, because now we see for this event type, we will get this result. For this event type, we get this result, and etc. And then the usage of it becomes also super easy. We just reference the table and we provide a type, and we get the same result back. But lookup table can get us only this far, because even though it kind of helps with the first issue I have mentioned that I had with original code, that if something has changed with the types, if there is a new type, for example, primarily thanks to the Typescript, we will handle that new type. Let's say there is a type erase. So now our lookup table forces us to handle this type in some particular way. We're now missing that event type key. Same goes other way around. If we remove some event, we need to update our table accordingly. But unfortunately, lookup table can get us only this far, because it's really hard to handle some more complex cases with a lookup table. Let's convert all these events into some more complex objects and see the problem. So now we have replaced all the events with more complex events. Now we have start draw event that also has the coordinates from where we start drawing. We have draw event that has path of all the points we kind of go through while we're drawing. And then we have end draw event where we stopped drawing. And then the drawing event is discriminated union of all of those events. And then we have an array of those events. Here we updated also our input. So previously we could create a lookup table by specifying the type. We can do the same now. But now we cannot just create a mapping between a type and a string, because we have different attributes that we might want to incorporate in those results. So we need some kind of function. But then the function is different for every type of event. Even if you can create a table out of this, it becomes quite cumbersome. So do we need to get back to this if, else, if, else, if, else, if situation? No. Because there is a very cool thing that exists in other programming languages, but unfortunately it doesn't have the native representation in the JavaScript, which is called pattern matching. Right now, pattern matching is in stage 1 proposal for TC39, so I don't think we're gonna see it anytime soon. But thanks to the beautiful people out there in the world, we have a library that will help us create pattern matching based solution. And the library for that is tspattern. So we start by importing function match from tspattern. And then for our createLog function, we will create a flat map of all events. I will show you why we create exactly flat map and not just map. So we basically map all the events through pattern matching. So when we get event, we pass it into this match function. And that match function allows us to then match it with some pattern. And there is quite plenty of different things we can specify here, but the only thing in our case is to specify that we're handling a type. So when tspattern match function, it recognizes this pattern that if event has this type, then it's know that it's of that type, so that it's a start draw event, meaning that it can parse and then we can have another function that has all the properties of that event extracted so we can get access to it. So here we do the same for the draw type and we get path, but since path is an array of points, I was thinking that it would be easier if we create flat log where every event happened is just a string. That's why we had, since we need to map over path, we need to flat map over events. This library comes also with this beautiful exhaustive function. With exhaustive function, we make sure, again, that like with the lookup table, we don't really miss any type. So now if we introduce some new event type, like for example this add text event type, and now we have a drawing event which has add text event type, we now see that exhaustive is angry with us because it says non-exhaustive error add text event. So we need to write a handle for that event and we're good to go. So we will do exactly that with type add text. It's very helpful to show us that there is exactly this type is missing. And now, since we know that it's this type, then we get access to all the properties of that type, which is text and position. And then when we run, we get exactly all the strings we want to output in our log. So next time, before writing multiple else-if statements, I will think whether maybe it's time to bring a lookup table, or maybe I should use pattern matching with something like TS pattern. By the way, the examples covered so far in this video particularly, just a fraction of what TS pattern library can do. Consider to check it out as well.